from chapter 10. All right, so this is our last surface area and volume lesson. Here's the thing you need to do. Memorize your formulas, memorize your formulas, memorize your formulas, and start working on your test review. You're not going to want to do it all on Tuesday night. I think a large group of you should have been probably started this weekend like I asked you to, but guys, really just kind of keep this in your mindset. I was finishing up basically doing the rest of the year on Academy Central. You have this test and one more. You have some quizzes in there, and that's about it. You're that close to being finished. So does this really matter? Yeah, it's a big chunk of your grade. So you've got to make sure that you guys are studying for the test. So let's make sure we have this one down. It's kind of a fun day, it has some different stuff on it, but we're actually talking about, we hadn't talked about before, we're actually talking about spheres. And one reason why we're talking about sphere at the end is there is absolutely no polygon in it, right? It is just that ball that you would expect. But if the definition is so similar to a circle, you have to be very careful with how you word it, okay? So we want to make sure that we have it. So let's write the definitions down. Let's label its different parts because there's not a lot of parts you're going to label with a sphere. But let's go with it from there. All right, so what is a sphere? Well, if it's going to type it for me. A sphere, now it says a locus. Well, a locus is just a group of points or intersection of points. So let's just change that to a set. A sphere is a set of points in space. So it's three-dimensional, that are fixed distance from a given point. All right, what's that given point always called, guys? The center. Same just idea as if you're doing a circle. So right here, there's your center. And so again, the center, the location of it, obviously that means we're going to be able to locate it. We're going to use distance formula, a lot of different things we're going to use. We also still have a radius, and really that's the main thing you need to know. Your radius is just that line segment that connects the center to any point on the sphere. Now, how many radii does a sphere have? Infinite number. They're just all the same. Now, if I have a radius, even though that's not on here, could I have a diameter as well? Can I? Yeah, so I have a diameter as well. So the idea of diameters is still the same idea as before. Talking about how to find the center of stuff, same as before. It's just that you're working with it three-dimensionally. All right, also we have what's called a hemisphere. Now a hemisphere, what makes that really nice, it's just literally half a sphere. Now, how many times have you in geography, guys, have learned Western Hemisphere, Eastern Hemisphere, Southern Hemisphere, Northern Hemisphere? Hello, you're just talking math. They were just dividing it into half the earth, right? So same type of scenario. Also, we have one other one. It's called the Great Circle. Now, make that look like a C instead of an E, and I'd be okay here. It's not going well. All right. It's the Great Circle. What in the world is the Great Circle? Well, first of all, let's label it on here. Let's label our hemisphere. A great circle divides it equally in half. Here's another way of talking about it. If I was to take a plane and I was to go directly through the center, it's the circle that you get. It's the largest circle that you'd get if you intersected it with a plane. And they call it the Great Circle. Now, again, are there infinite number of great circles I could do? Yeah, I could divide it perfectly through the center of a circle many, many times. All right? So the fact is you have many great circles, but the largest one is always the one that directly, if I take a plane, go right through the middle, it's the cross section that I get every single time. Does that make sense? All right. Now, with this one, we're actually going to go a little bit backwards. We're actually going to talk about volume, and then we're going to turn around and talk about surface area. How's that for going a little bit different direction with things? But notice, did I talk about the height at all of this sphere? I don't need to. There's only one thing you ever really have to know about a sphere. It's called its radius. That's all you have to know. So does it matter if I talk about surface area first or volume first? I only need to know the radius. So why do I want to talk about volume first? Well, there's a couple different ways of talking about how to calculate it, and I'm not going to take tons of time to work with you on it, but let's talk about Cavalari's principle for a moment. Remember, Cavalari's principle says if you're at the same height and you have the same cross section, then you have the same volume, right? Now, here's how funky this is. Notice I've got a sphere with a cone taken out of it. I mean, a sphere, and I also have a cylinder with a cone taken out of it. But notice if I do a cross section of the sphere and of that funky cylinder with a cone taken out of it, I get the same area, same cross section. So I can actually use that to calculate the volume of the sphere. So let me show you how it's done. I'm showing you the math. Notice I'm not letting this. All right, why did I include this? Because this is one of those goofy things like Gregor said, no one really cares. Here's why. There's always someone who does. There's always someone like, where did that come from? This actually shows you the math behind it. So how did I get the volume of, notice a hemisphere is what I started with, not a full sphere. So I have a hemisphere, it's the volume of the cylinder minus the volume of the cone. And look at this, good old algebra skills, getting a common denominator. Oh, look. We also then use the idea we have 2/3 pi r squared times the height. Now, height, where did h come from? Height, remember, is how tall something is. Well, let's go back for a moment. If I'm looking at my hemisphere, what's the actual height of a hemisphere? It's what? The radius. So notice they plug r in for the height. Now, again, this is the volume of a hemisphere. Well, a sphere is how many hemispheres? 2. So you just multiply it by what? 2. There's your volume of the sphere. It's 4/3 pi r cubed when we work with it. So the volume is just 4 pi r cubed over 3, or you could say volume is 4/3. Can't make the thirds stand out though. 4/3. I can't write today until it's a Monday morning after a break. Pi r cubed. Either one of those work. Again, when would I use the one on the right? If I have fractions. When would I use the one on the left? When I don't. So it makes it easy to work either way with it. So that's it. You just have to know the radius. Nothing too exciting, is there? So let's do it real quick. It says, find the volume of the sphere. Give your answer in terms of pi. Now, what did I give you guys on this first one? Didn't I give you the diameter? Well, what's your radius going to be? Isn't that just going to be 12? Now, when you're working with this, it says leave your answer in terms of pi, guys, so make sure you do that. I'm going to use 4 pi r cubed over 3. By now, I think most of you are pretty good much believers about writing your formula down with your work directly below it. But all you have to do is plug it in. 4 pi, well, what's being cubed? 12 cubed all over 3. All right, so how do I know if this is going to have a fraction for an answer or not? If the 3 cannot divide into the radius, you're going to have a fraction, and you'll leave it as an improper fraction. But in this case, it can. So someone punch that into your calculator. What do you get? 12 cubed times 4 divided by 3? 2,304. What comes along, guys? Pi cubic inches. What do you guys think? Easy? That is true. All right, it says now find the diameter of a sphere. Notice I went straight there. Okay, sorry, we're going to do a straight tail workout backwards problem, guys. We're not going to waste our time doing tons of volume formulas when you can plug and chug in. But now it says here, find the diameter of a sphere with the volume of 36,000 pi cubic centimeters. Guys, what type of problem is this? Yeah, it's a work backwards problem. So let's do it real quick. So with this one, I'm going to use my formula. So I get the volume is 4 pi r cubed over 3 equals, all right, pretty large numbers, 36,000 pi equals 4 pi r cubed over 3. All right, guys, what are we going to do first? Multiply both sides by what? Multiply both sides by 3. So now I'm going to get 108,000 pi equals 4 pi r cubed. What are we going to divide both sides by? 4. Yeah, I'm going to divide both. I'm going to do 4 pi just to kind of kill 2 birds with 1 stone, right, guys? All right, so what do you get? Someone do that real quick for me. What is 108,000? 27,000. That's everyone's favorite number. 27,000 equals r cubed. Uh-oh. This is disastrous. How do we do this? We're only used to working with what? Don't you think your calculator can do this, people? Come on. We know how to cube things, right? When you cube something, you multiply something by itself how many times? 3 times. Well, what's the opposite of cubing? Almost. It's called the cubic rooting. All right, I'm going to take the cubic root of it. I'm looking for a number that can be multiplied by itself 3 times. Now, it looks kind of funky. Here's the symbol that you're going to get. And you're going to do a lot of this next year in Algebra 2 and College Algebra. You're literally going to write a square root symbol over it. But over here, you're going to put up above a 3. And that's going to give us our value. Let's see if I can get it to write. However, it doesn't want to write for me. All right, so I'm going to take the cubic root of r cubed. So basically, it's like taking the square root of cubic root. Now, how can we do this? Well, let me show you. We can do this on our calculator. Oops, wrong one I wanted to do. Here we go. This is when our calculators are our friends. All right. Close. I'm going to clear everything. All right. So how do you do this? Well, guys, here's how fast it is. Go to your math key on your calculator. So hit math. Make this a little bit smaller. Oops, did not want to do that. Does not want to. Did not help me. Oh, well. All right. So go to math key. Guys, do you see number 4? Go to number 4. Either arrow down number 4 or push number 4. Notice how it's the superscript with our radical there. Then put 27,000 in. Hit enter. Did you guys get 30? Awesome. So you should get here on this one, r equals 30. Now here's the cool thing about cubic roots. You can actually have negative numbers now. With square root, can I take the square root of negative numbers? No. But with cubic roots, you can, because a negative times a negative times a negative is a negative number. So understand it's a little bit different than square roots, some common sense stuff, but look how easy that is. R equals 30. Guys, what's your diameter going to be? Yeah, your diameter is just 2 times 30, which is going to be 60 what? What's your label going to be? Centimeters. Guys, what do you think? Isn't that kind of fun? Yeah, now there's other ways you can do this. I'm going to let your math teachers next year teach you, because you could raise it to the 1/3 power. There's like a lot of fun stuff that you can do. But let's make sure that we can get the next one. All right, same type of problem. Find the radius of a sphere with the volume of 2,304 pi cubic feet. So it's another work backwards, right? So let's do it. Let's work backwards. Our volume formula is going to be 4 pi r cubed over 3. So our volume is 2,304 pi equals 4 pi r cubed over 3. Guys, we're going to do the same process that we did earlier. Yeah, in fact, I'm going to move this over so I have a little more space. All right. So with it, multiply both sides by 3. What'd you guys get? 6,000 what? 6,912 pi equals 4 pi r cubed. Divide both sides by 4 pi. What do you guys get? So 1,000. All right. 1,728 is equal to my radius cubed. So we're going to do to both sides. Cubic root it. All right. Quick review. Where do you go on your guys' calculator to this? What's the easiest key? Go math. All right. I don't know why this is not giving it to me like normal. That's so strange. I have no idea why the view is doing this. All right. So you just go math. Number 4. Plug it in. Was it 1728, right? Did you guys get 12? What do you guys think? Something that could be very complicated but is actually really easy. So it'd be 12 what? Feet. Don't forget labels and to label carefully. Guys, I had some people on the quiz cube everything because they're still working with volume. So anytime they did surface area and lateral area, they put cubed. They got half a point taken off at every single problem that they did that on. So be very careful. All right, guys, what do you think? Easy? It's not too bad, is it? All right. So let me put this back on tablet mode so I don't mess up. All right, surface area of a sphere. Now, this is if I was a brilliant hands-on teacher, this would be the moment I'd come in and I'd bring you a beautiful orange in class. And I'd give everyone an orange. And I'd sit there and tell you to take an orange and you would trace around the orange so you get like basically what the great circle would be. And then I'd ask you to do that 4 times. Then I'd say, pill your orange. But always put a pill in one of the 4 circles. And what you'd find out is that your pills for your orange would fit perfectly into those 4 circles. Every single time. It's because basically the pill of an orange isn't that like your surface of your sphere. It takes 4 great circles to cover your sphere. Isn't that kind of a goofy thing to do? Like, this is nerdy, go home, eat an orange, clementine, whatever you need to do. It will come out the same way. Like 4 great circles will make that. So if you know how to find the area of that circle, what's the area formula for that circle, guys? How do I find the area of a circle? Pi r squared. Your surface area is just 4 of those. 4 pi r squared. That's all you have to know, and you don't have to have the parentheses if you don't want. It's 4 great circle areas. So if you're given the area of the great circle, you just have to multiply it by 4. That's it. If you're given the radius, plug and check into the formula. It's that simple. Darn. Nothing exciting about this, sorry guys. But yeah, literally, you could goof off with like any circular fruit and the peelings would actually fit into 4 great circles. I don't see any of you doing that for fun, but you could. You could. And I'm going to give Mrs. Prempus credit. She's the only person I know that's done it here since I've been here. So she had fun and peeled it and actually did in class one day. So she was the good teacher. So we're giving Mrs. Prempus all the credit. All right. Let's head out, guys. Let's figure this out. It says find the surface area of a sphere with a diameter of 76. Guys, what do you need to know? Radius. All right, so what's our radius going to be? Yeah, radius is going to be 38. Your surface area is so easy. Write your formula down. Plug and chug it in. So we get 4 pi. Our radius squared is 38. Should be a fairly large number. All right, what do you guys get? I believe your answer in terms of pi, my friends. Yeah, 5,776 pi. What's our label going to be? Rough day, isn't it? Yeah, that was said with sarcasm, yes. All right, that's how easy spheres are compared to everything else we've been doing. 2 simple formulas. If they ever ask you for lateral area, be concerned. Notice I never talked about lateral area because what don't I have on a sphere? Do I have a flat surface? But on a hemisphere, could I find lateral area? Yeah, because your great circle ends up being the base. So understand the differences between them when you're doing it. All right, go ahead and do the next one. You don't need me, so just do it. See if you get the right answer. Do not give me a mixed number for an answer. Improper fractions are what you guys can get used to using. How'd you guys do? Are we getting it? Should have 256 pi square centimeters for the surface area, and your volume should be 2,048 pi all over 3 cubic centimeters. Now, here's the thing. I have about 2 people in this room I know. I have taken off points on their quizzes and tests because they will give that to me as a mixed number. Like the second one, the volume, they will put there and they'll put something like, I'm just making this up off the top of my head, but let's just say something like 635 1/3 pi. Because what that happens though, it looks like you're going 635 times 1/3 times pi, correct? If you don't put that mixed number in parentheses, I'm not going to give you the credit for it. But the thing is, just leave it as an improper fraction and move on. Almost every math class from here on out prefers improper fractions. Less work you have to do in the long run. Are you guys with me on those? All right, let's crank out some more problems. Basically, I want you guys to be so solid with spheres before you do your homework. Homework is a breeze when we're working with it. All right, so this one says, find the volume of a sphere with a surface area of 324 pi square inches. Give your answers in terms of pi. All right, guys, talk to me. What do I have to do? All right, you're all doing it, but you're supposed to tell me what am I supposed to do. Work what? I gotta work backwards. I have surface area, I just need to find volume. So I need to work backwards with this. So surface area, what's the formula for surface area? Who's got this down already because it's so easy? Sophie.
4 pi r squared.
So 4 pi r squared, so I get 324 pi equals 4 pi radius squared. All right, guys, some of you are cranking out the numbers already. What is 324 pi divided by 4 pi? What'd you guys get? 81. All right, so what's your radius going to be, scholars? Yep, your radius is going to be 9. So now I can just plug it into our volume formula. Again, always, always, always write your formulas down. Also, don't forget to divide by 3. A lot of people will forget that when they're in a hurry. So I get 4 pi times 9 cubed. Make sure you cube that 9, not anything else. And then tell me what you guys get for that when you're done. Jaden, what did you get? Yeah, there's other calculators in this dash you can use. What'd you guys get? Yeah, 972, right? Pi, and what's our cubic inches? Is that right? Guys, that's how easy it is. Okay, for the next one, please don't overthink this. How many of you would be like automatically, like, I'm just going to solve for the radius? If you did, are you going to be right? Totally. But what's the nice thing that they told you? It told you the great circle is what? They gave you a great circle's area. Remember, your surface area is 4 great circles areas. So really, can I just go 4 times 49 pi? Do I need to, basically what I'm saying is, do I need to recalculate this circle area? No. I can just plug it in. And you are going to end up getting something like 196 pi square miles. That's a large sphere. All right, I think, didn't we already do this one? Nope, we didn't. Oh, no, we didn't. But we did. Look at this problem. It says, find the surface area of a sphere with a volume of 2,304 pi cubic feet. Did we do something with that already? Guys, look back. Did we work backwards to find the radius of that sphere already? Because if I want to do surface area, isn't that what I need to do? So the thing is, yeah, I could totally work backwards again, but should we really do that, or can we say see previous problem? What do you guys think? Isn't like that the third problem too? Yeah, so it's the third problem. So let's just say see third problem. So for how to solve for R. How's that for not recreating the well? Does that work for you guys on this one? So because it's a work backwards problem, because I have volume and I'm looking for surface area, which means I do have to solve for the radius. But the cool part is we've already done this. Guys, what was the radius on the third problem? What did we get? What, did someone flip back? What was it? 12? All right, so the radius is 12. So now I can just put it in my surface area formula. So 4 pi r squared. So whatever 144 times pi is, what'd you guys get? What'd you get, Paige? Did you get the answer?
Yeah, I got it. Are we supposed to leave it?
Yep, in terms of pi. Yep, if I don't tell you, always leave it in terms of pi.
Okay, I got 576.
Perfect. That's what I got too, so 2 of us are right, so that's a good start. All right. Guys, work with me now. It says find the volume of a sphere with the surface area of 900 pi square centimeters. Do you guys think you can do it? Go for it. Get it done. It's another work backwards one. This one should work out to be a pretty nice number when you got it. What did you guys get? What did I hear it? A little louder? Yeah, 4,500 pi cubic centimeters. Guys, is this really any different than what we've been doing? Now, I'm going to warn you. You think your homework's going to be this nice?
No.
No, I'll tell you right now. You're going to get answers with fractions like something like 3 over pi. Like you have to trust your math. This is hard for you guys, I know. Trust your math, okay? So you might actually have answers with pi in the denominator. It's okay. All right? So make sure you're just being very careful when you're working with these. All right, I had to have at least one fun problem in here. It says, find the surface area and volume of the composite figure. Give your answer in terms of pi. All right, talk to me. What would I do here, guys? Well, the lateral area of the cylinder is a good way of thinking about it, definitely. And then add what to it? Maybe add to one, right? Add one base. Like that way you don't have to worry about both bases. So basically almost like make the cup, finding the surface area of the cup, because you don't want to. The key thing is, I don't want this, do I, guys? I don't want that one. So the idea is if I look at the cylinder type shape, and I'm just wanting to take the lateral area plus adding one base on, that makes a lot of sense, right? How about for the hemisphere? Can I just take half the surface area of a sphere? Would that work? All right, so that would give us the surface area, and then we'd have to be able to do the volume. So how about if we do it this way? How about if we find the surface area of the hemisphere, and we talk about the volume of the hemisphere, and then we do the surface area of kind of the cylinder and the volume of the cylinder, right? Let's just do those together, and we'll just do it, and then we'll just do our total values at the end. Does that make sense? All right, so let's do the first one. Let's do the hemispheres first because they're the easiest, all right? So the surface area of a hemisphere. Basically, is 1/2 the sphere. So you guys agree with me? It's just going to be 2 pi r squared. So let's just plug it in. So what's our radius going to be, guys? Yeah, our radius, because the diameter is 12, our radius from here to here is going to be 6. So we get 2 pi times 6 squared. Well, 36 times 2 is just 72 pi. All right, so that gives us the surface area of the hemisphere. We need to do the volume of the hemisphere, which is going to be 1/2 the volume of a sphere. So that's really 2 pi r cubed, not written well there, over 3. So I get 2 pi, my radius cubed is 6 cubed. What do we get for that one? Someone do that on your calculator for me. 6 cubed times 2 and divide that by 3. And bring your pi along. It should be 144, right? So 144 pi. I don't know why I'm labeling this, but I guess it's okay to be inches squared, but we don't need those labels yet. All right, so we got the parts of at least the hemisphere taken care of. Now we have to find the surface area of the cylinder, and this is how I wrote it in my notes. Surface area of cylinder minus 1 base is how I wrote it. Did that kind of make sense? So that way when I'm working with it, we know the surface area is going to be 2 pi r h, which is my lateral area. And I said plus, I'm subtracting 1 of the bases, so doesn't that just leave pi r squared then? So I have 2 pi r squared, I get what? Pi r squared. So then you can just plug it in. You got 2 pi, my radius is 6, my height is 9, plus we got pi times 6 squared. So 2 times 6 is 12, 12 times 9 is 108 pi, plus 36 pi. I got 144 pi. In this case, that's going to be in squared inches. So that's the surface area of that cylinder, plus subtracting that 1 base we didn't want to count. And now let's do the volume of the cylinder. Nice thing about the volume of the cylinder, we don't have to worry about subtracting anything out. It's just going to be 4, whoops, excuse me. What do you got? Pi r squared times what? The height. It's the area of the base times the height, so it's going to be pi r squared times the height. Just plug and chug it in, which is nice. I get pi times 6 squared times my height of 9. What'd you guys get for that one? All right, who's got the number for me? Yeah, 324 pi, and that would be in cubic inches. All right, now let's just finish this all out. Let's find the different things. I need to find the surface area and the volume. I still haven't done that yet. I've done each of the parts. I got to put it together. So if we're doing the total surface area, that's going to be the hemisphere plus the cylinder minus 1 base. So what do we get here? 144 pi. I got that to be 216. Someone double check my math. 216 pi square inches. So that's going to be the surface area. I still need to do the total volume yet. I do the sum of the parts equal the whole. I get 144 pi plus 324 pi, which equals and 68 pi cubic inches. All right, guys, that was more time consuming, but not impossible, was it? Does it make sense? The key thing with surface area, just like any other time, is don't double count something or count something that's not on the surface. That's it, guys. You actually have 5 minutes. Guess what you're going to do for those last 5 minutes, and it's not goofing off and talking to your neighbor. You're going to work on your homework.